So, looking at this one here, part A is given in the formula sheet, as I said, so you don't need necessarily to know the derivation. Worth having a look at, just on the safe side. But the word hence there is sort of implying that somewhere within this, I'm going to be using the first answer in the second part. In part A, they would probably give you a bit of a clue about how to do this, but we'll see if we can work it out without that little clue, and I'll tell you what the clue is when we get there. So, first thing I'm going to do is integrate tan x. Any suggestions what we could change tan x into which might give us a chance of integrating it?
No. And then like different sex
That's, if you differentiate tan x, just, yeah, you're close. It's actually, we're going to use sine over cos.
Yeah, I meant that.
Yeah. So I've just rewritten it. So I haven't integrated, differentiated it, done anything to it. Now the clue that they'll probably give here is, they would say it's a substitution, and they'd tell you what the substitution is. Anyone would like to guess what the substitution might be?
Cos x.
Okay, good guess. So u is equal to cos x. So du by dx is equal to
Minus sine x.
minus sine x. And so therefore dx is equal to
Du minus sine x.
so it's du over minus sine x. Good.
Don't know that one. Didn't you put it into y into the equation over there?
What am I putting into this one?
No, into.
Oh no, I'm not doing this one by parts, that's part B. This is a substitution method.
Oh, okay, so we're just doing the original, like the song we did.
Exactly. So what we've got in here then is I've got sine x over cos x. Actually cos x we can replace that with u, so let's do that. Times by du over minus sine x. They cancel out. And we're integrating minus 1 over u du. What's the integral of 1 over u? ln u. But u was equal to cos x. Now, if you look, our thing is fairly similar to the log sec x thing, but it isn't. What else is different as we compare this thing to this thing? It's cos not sec and negative. So the next step is to rewrite it so that the minus 1 isn't at the front there, but it's inside, and it comes inside as a... How do I move that minus 1 into here?
Because it can't be negative.
No, it's not because it can't be negative. It's a bit like if I had 2 log x.
If you divide it or something.
Not divide, it's that kind of idea. 2 log x is the same as log of x to the power of. Good. So this becomes to the power of minus 1, which as Katie says, is 1 over cos x.
Is that the whole of cos x that's to the power of minus?
Whole of cos x is to the power of minus 1.
That's quite clever.
Okay, so that's how that first bit works. As I've never seen it as, perhaps this year could be the first. Who knows? So that's just using the substitution method, which we used a couple of weeks ago now. Part B is using the by parts method. So if I look at part B, I've got this formula here, which is given on the formula sheet. It's a case of assigning u and dv dx accordingly. So if I'm integrating x sec squared x dx, so I need to work out what u is, what dv by dx is, and then use those to get du by dx and v. Any suggestions what we might want u to be and what we might want dv dx to be? It's not necessarily in order. Have a guess. Well, the question to ask yourself is sec squared. Can you integrate it? Can you differentiate it?
You can differentiate.
What happens if you differentiate it?
What do you make it to tan?
That's not integration. That's the other way. So I can integrate sec squared to get tan. So is it sensible to use u as sec squared or dv dx as sec squared? dv dx. So dv dx is sec squared x, and I can integrate that to get tan. If I've used sec squared up, the other one here is x, and the differential of x is 1. So that's all the working out that I need to do. And then I can swap that into this formula. So UV,
Sorry, where did the A come from?
where did the what come from?
A equals X.
Oh, that's U, sorry, not an A. Just joined together. So that's just U. And then I just swap it in. So I've got UV, so X tan X, minus the integral of this times this, V times d dx, so this times this. So that's 1 times tan X, which is just tan X, dx. And because I've done that in the first part, I can say, okay, well, all that's equal to X tan X minus the integral of tan X is log sec X plus C. And I'm done.
But then wait, in the formula is it UV
Oh,
minus